Dear student, actually, today now let's see the solubility topic. The solubility is nothing but at a particular temperature, it's a particular temperature, the maximum amount of solute dissolve in the solution. Maximum amount of solute dissolve in solution. Okay, so that is for the solubility. So in generally the formula, the solubility is equal to weight of solute, weight of solute divided by weight of solvent, weight of the solvent into 100. So this formula is for the solubility uh, calculated. If may asking the problem, we can go to this formula. So now the solubility, there is only two types of solutions. Previously we studied the general 9 types of solution. Among that, the two types of solutions. For that, first case as solid in liquid solution, solid in liquid solution. Okay, so here solid as a solute and liquid as a solvent. Then second category, see here the gas in liquid solution. Here gas as a solute and liquid as a solvent. Okay, so gas as a solute, liquid as a solvent. So these two category we will discuss in this in this video one by one. So first of all, the solid in liquid solution. The solubility, the first case, that is a solid in liquid solution, in liquid solution. The first case actually this the solubility in generally depends upon the following factors. So there is a following affecting the factors or factors affecting. It's a factors affecting. So among these two solution, those three factors are affecting. So first case or A here representing first case as nature of solute and solvent. Okay, so second case as the temperature and third category as pressure. So for these three factors are affecting the solubility, either these two types of solution. Okay, so whatever that the solution, they have affecting the solubility among three factors. Okay, now we go to the factors. The first case as there is a nature of solute and solvent. Now there if solute and solvent are similar nature, solute and solvent or similar nature, they have soluble. Similar nature or uh, similar nature, they are soluble. They are soluble. Okay. For example, the solute, and here is a solvent, and there is a solubility. Okay, the solute has polar, and the solvent also there is a polar, or the solvent and the solute are non-polar. There is a non-polar, and here also solvent non-polar. So both polar and non-polar are there is a soluble. Soluble. If the solute are polar, and solvent are non-polar. Okay, for this category, or the solute are non-polar, and solvent are polar. For this kind of category, are insoluble or less soluble. Okay, so it's a very easily understood. For this kind of nature of the solute and solvent, both the solutions, actually gas, liquid solution also is followed. Okay, so the next, if not ionic compound or if not polar, and generally if not ionic compound, the solubility is directly proportional of the hydrogen bonding. Okay, for this is also the solubility are proportional to the hydrogen bonding. It's most useful. For example, the ethanol in water, ethanol in water, also then sugar in water, and urea in water. There only the hydrogen bonding are present, and that's why that is a soluble in the polar solvent of water. Okay, the next, the effect of temperature. There is a next factors. There is a temperature. This separated by three category. One is the temperature as a inversely proportional to of soluble. Temperature inversely proportional of the solubility. Okay, for this kind of category, the dissolution of substances are exothermic. There is a dissolution of substances or solute exothermic. exothermic Okay, so let's see this for future video. The exothermic and endothermic, exoergic or endoergic, where we to where will where how we'll say that exothermic or endothermic, like that. One thing you understood, exothermic means wherever the system or removed energy. The system is removed energy, actual energy of the system is reduced. Okay, so the temperature or decreases, the solubility or increases. So because of temperature or inversely proportional of the solubility. In general, the dissolution of solute or exothermic, so that's a temperature or inverse of the solubility. Here that is an example of cerium sulfate, and lithium carbonate, etc. So those are the example of the temperature inverse of solubility category. And then second category, here there is a the substances increases of solubility with increase in temperature. So there is a temperature as a directly proportional of the solubility. Okay, for this kind of category, that is the substances of dissolution, there is endothermic. Okay, so there is a dissolution of substances or solute or endothermic in nature. Okay, endothermic means we know that, or just you understood, the system or gain the energy from the surrounding. Okay, so that is why the temperature are directly proportional of the solubility because of dissolution of solute or endothermic in nature. Here there is an example of there is a sodium chloride, potassium chloride, so there is a etc. So like that compounds or dissolution of substances or endothermic nature. So that's why temperature as a directly proportional of solubility. Then third factors, there is a third category of temperature. Okay, here the temperature are independent of the solubility. Independent means whether the temperature increase or decrease, whatever that, the solubility does not affect. The temperature are independent. Okay, here the temperature increase or decrease, but the solubility are not affect. Solubility not affected, not affected. So in this category, okay, so for example, all hydrated salt, there is a example of this type, because there's a polymorphic form, one form to another form, hydrate to another. Okay, so there is an example of, there is a polymorphic forms. Okay, polymorphic forms salts or example. So now calcium chloride dot 6H2O, it's given of temperature, there is a calcium chloride dot 4H2O gives, there is a again given the temperature or thermal energy, calcium chloride dot 2H2O. So this one kind of form, this and this also. So that's why there's a polymorphic form. Here one phase changes to, or one form changes to another form, so the temperature or transition temperature. So there is a transition temperature. So here there is a one form to one form to another form, that is a temperature or transition temperature. Okay, so this is also most important. The transition temperature, see the graphical representation, actually there is here solubility and there is a dissolution of a solubility uh, or the solubility here as a temperature. So now the sodium sulfate is using, the gradually increases then decreases like that. So for this curve to here, there is a sodium sulfate sodium sulfate dot 10H2O, Na2SO4 dot 10H2O, and this Na2SO4. So this temperature or the transition temperature of sodium sulfate. Okay, okay. Then last category, that is a pressure. So there is pressure solid or independent of pressure, because of See, the solid cannot be pressurized. So if you apply the pressure, there is a broken. See this pen, there is a solid. There cannot be pressure apply here. So pressure is invalid for that solubility in this in this solid liquid solution are not affected by a solid in liquid solution. Okay, so that is not affected because of solid or incompressible. Solid or incompressible. Okay. So for upcoming video we will see that gas in liquid solution, how there the solubility are affecting those factors. Okay, thank you to all. If you like in this video, subscribe and share your friends. Thank you to all.